This week on the show, we have FreeBSD on the Google Pixelbook. We have a report about porting the NetBSD to the AMD x86-64 way back when. ZFS performance, which really starts degrading as you approach the quota limits and why that is. Fixing up the KA9Q Unix. We talk a little tiny bit about Hammer 2 and fsck, and the return of startx for non-root users in this week's episode of BSD Now. BSD Now, episode 320, Codebase NEC-D, recorded for the 16th of October 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Ju.
And welcome back to another episode this week. Glad to have tuned you in, or you tuned into us. We have interesting headlines, as always, starting off with FreeBSD and custom firmware on the Google Pixelbook.
Yep. So this is... I say back in 2015, I jumped on the ThinkPad bandwagon and got an X240 and ran FreeBSD on it. Unlike most people in the ThinkPad crowd, I actually liked the ClickPad and didn't use the track point much. But this summer, I've decided that it's time for something newer. I wanted something that was, A, lighter and thinner. And I say, it turns out that it's actually important. I got tired of carrying a thick laptop. Apple was right all along. While I will agree that my X270 was quite a bit thinner and lighter than my P530 with the second battery, which was a worst case example almost. I do think the thinness thing can be taken too far, where I end up needing to carry an entire bag full of dongles. That's why I like the X270. Has real Ethernet port, doesn't require a dongle, etc. It's the right compromise for me. They wanted a 3x2 display. And they say, why is Lenovo making these serious work laptops 16:9 in the first place? 16:9 is awful, especially in your below 13-inch size, especially. I would say that is the one thing I like about my Mac is the higher resolution.
Oh, yeah.
But I have terrible eyes, so I'm kind of okay with low resolution at the same time. Like I have to turn the amplification or whatever up on my Mac so much to be able to see anything anyway. They like having high DPI. Sure. USB-C ports, very nice. My ThinkPad X270 does have that, so it's good. I say without a dedicated GPU, especially without an NVIDIA GPU, just has the built-in Intel. Whereas, yes, my T530 had the dedicated Intel or dedicated NVIDIA, and it definitely hurts battery life having a bigger video card. And they like something assembled with screws and not glue. Yes, ThinkPads are pretty good for being able to be taken apart, especially. And they wanted to have support for running FreeBSD with, some development required is okay, but I don't want to have to write any of the big drivers or anything.
Yeah.
And, something with open source firmware would be great. So they looked at Qualcomm's AR64 laptops were out because the embedded GPU needs freed Reno and the UFS storage driver and Qualcomm Wi-Fi and so on has not been ported to FreeBSD because Qualcomm firmware is very cursed. They looked at Samsung's RK3399 Chromebook or the new Pinebook Pro. Those would have been awesome if I were a Linux user. No embedded GPU driver on FreeBSD again, and no one was adding the stuff needed for the flattened device tree or open firmware attachments to the Linux KPI. It's rather tedious work, so we only support PCIe right now. And can someone please make ARM laptops with a PCIe GPU or something like the MXM slots? So it's still going to be AMD 64 for now. I really like the design of the Microsoft Surface Book, but the iFixit score is 1, which is really bad. And especially the Marvel Wi-Fi chip, that's not going to have a driver for FreeBSD. They considered a ThinkPad X1 Carbon, maybe from one of the slightly older generations, as the The one from the same year as the X230 is core bootable, so that's fun, but goes back in processor generation. Doesn't seem to make sense for a new laptop. Then I discovered the Pixelbook. Other than the one big, huge, large bezel around the screen, I liked everything about it. Thin aluminum design, 3x2 high DPI display, rubber palm rests. Why isn't every laptop doing that? The convertibleness, flip the screen around and turn it into something kind of like a big tablet. The Wacom touchscreen that supports a pen, mostly reasonable hardware like Intel Wi-Fi, and the fabulous core boot support since Chromebook's stock firmware is core boot, plus the depth charge stuff. So here it is, my new laptop, a Google Pixelbook. And so they get in a little bit about what is a Chromebook and some of the different aspects of it. And they say, you mentioned something about FreeBSD in the title of this. I say, okay, let's go. I didn't even want to write an introduction to the Chromebook, but here we are. Anyway, we're waiting for the debug cable to arrive. I've done a lot of work on FreeBSD using the first method, the RW legacy. So CBIOS does not have display output working in OSs that don't specifically support the core boot frame buffer. OpenBSD does, but FreeBSD does not. And I really hate legacy BIOS anyway, so I've been using the UEFI implementation and then putting it in legacy mode. The live USB booted fine, and the EFI frame buffer, the NVMe SSD, and the keyboard are all basically working. I've resized the Chrome OS data partition, and Chrome OS recovered from that fine without touching custom partitions. Found that it's already an EFI system partition, so I just have to add the files to that. And it went. And they say, I'm leaving out the desktop configuration part here. That's in a different post if you're interested. They say Wi-Fi was easy. The Pixelbook has Intel 7265, the exact same chipset as my previous ThinkPad. So the Wi-Fi just works with IWM driver. The Bluetooth, however, is the newer 8265. If it was the newer 8265, it would have just worked. But these Intel devices present a normal USB Bluetooth adapter, except it only becomes normal if you upload firmware into it. Otherwise, it's kind of just dead hanging there. And so it manages to power it off to save some battery.
Yeah.
They say FreeBSD now has a firmware uploader for that, for the newer device, but it doesn't support the older protocol used by the 7265. Luckily, Google kept the keyboard as standard PS2, so that just works. Then you talk about the touchpad, display, backlight, brightness controls, suspend and resume, dynamic CPU frequencies, tablet switch mode, keyboard backlight brightness, and then using the debug cable with FreeBSD, audio. The only thing that's unsupported seems to be the onboard audio. The usual HDA controller only exposes the DisplayPort audio through the monitor thing. The speakers, mic, and headphone jacks are all connected to various codecs exposed via I2C. I'm not about to write the drivers for these codecs since I'm not really interested in audio on laptop anyway. And then they talk a bit more about firmware. But in conclusion, they have a Pixelbook with FreeBSD, Core Boot, and EDK2, and it's all good.
Okay. Yeah, seems straightforward so far with a little bit of tinkering here and there. So people can now start their own Google Pixelbook FreeBSD journey. The next item that we have in our list of great news item here is porting NetBSD to the AMD x86-64, a case study in operating system portability. And that's from actually a Usenix paper. And the abstract goes, NetBSD is known as a very portable operating system, currently running on 44 different architectures, 12 different types of CPUs. This paper takes a look at what has been done to make it portable and how this has decreased the amount of effort needed to port NetBSD to a new architecture. The new AMD 64 x86-64 architecture, of which the specifications were published at the end of 2000, with hardware to follow in 2002, is used as an example. So this paper is from BSDCon 2002. If you're wondering whether
nice. I see that now.
How new the AMD 64 x86 is. Okay, so there's a section. So they have multiple sections, of course, and they start talking a bit about what is portability. Supporting multiple platforms was a primary goal of the NetBSD project from the start. And as NetBSD was ported to more and more platforms, the NetBSD kernel code was adapted to become more portable along the way. Generally, code is shared between ports as much as possible. In NetBSD, it should always be considered if the code can be assumed to be useful in other architectures, present or future. Oh, that's kind of hard if you think about, the future, what kind of future architectures there might be. But yeah, if you see another architecture that could use this, definitely look at that of portability perspectives. So the paper continues. If so, is this machine independent and put in an appropriate place in the source tree? When writing code that is intended to be machine independent and it contains additional preprocessor statements, depending on the architecture, then the code is likely wrong or an extra abstraction layer is needed to get rid of these statements. And there are various types of portability. Assumptions about the size of any type are not made. Assumptions made about type sizes on 32-bit platforms were a large problem when 64-bit platforms came around. Most of the problems of this kind had to be dealt with when NetBSD was ported to the DEC Alpha in 1994. A variation of this problem has to be dealt with with the Ultra Spark 64 port in 1998, which is 64-bit, but big endian versus the little endianness of the Alpha. When interacting with data structures of a fixed size, such as on-disk metadata for file systems, or data structures directly interpreted by device hardware, explicitly sized types are used, such as uint32_t and int8_t, etc. So then the paper talks about device drivers. BSD originally was written with one target platform, the PDP-11, later a VAX in mind. Later code for other platforms was added, and 4.4 BSD contained code for 4 platforms. NetBSD is based on 4.4 BSD, but has steadily expanded the number of supported platforms over the years. As more platforms were added, it became obvious that many used the same devices, only using different low-level methods to access the device registers and to handle DMA. This led to, for example, 5 different ports having 5 separate drivers for a serial chip containing nearly identical code. Obviously, this was not an acceptable situation, with ports to new hardware being added every few months. To remedy the situation, the bus_DMA and bus_space layers were created, with the bus space layer taking care of accessing device I/O space, and the bus DMA layer deals with DMA access. For each NetBSD port to a new architecture, these interfaces must be implemented for each I/O bus that the machine uses. Once that is done, all device drivers that attach to such an I/O bus should compile and work without any extra effort. And then you have a section on machine-dependent parts, about tool chains, boot codes, traps and interrupt, as well as low-level virtual machine and MMU handling. VM is, virtual memory, not virtual machine.
Yep, and then there's a whole section on the actual 64-bit x86 hardware, the IA32 architecture, which is how to still run 32-bit stuff on it, the extensions, the registers, how memory management works, and then some work on the actual port when they actually made NetBSD work on the x86 64, and how some of that works.
Yep,
and then
with the usual
conclusions. In the end, looks like they had to add 300 lines of assembly and 3,000 lines of C to libc. And then the kernel got 3,300 lines of assembly and 17,000 new lines of code. And the linker was 60 lines of assembly and under 200 lines of code.
Okay, as a start, yeah. So that's interesting how the NetBSD project manages these various architectures and the support for drivers and all that. So that paper gives a good insight into that. All right, it's time for the news roundup this week. We have an interesting article from Chris Seibenman about ZFS performance really does degrade as you approach quota limits.
Yeah, it was odd to see somebody whose blog I read on a regular basis suddenly have my name in the blog entry.
Whoops.
Yes. So Chris goes, every so often, currently monthly, there is a OpenZFS leadership meeting. What this really means is lead developers from various ZFS implementations get together and talk about things. Announcements and meeting notes from these meetings get sent out to various mailing lists, including the ZFS on Linux mailing list. In the September meeting notes, I read a very interesting, to me, agenda item. Specifically, should we make a relaxed quota semantics for improved performance? problem as you approach the quota on your data set, your ZFS performance can go way down. This is on purpose. It's not a bug so much as a feature, but maybe you don't always need that feature. So the proposal is, can we maybe make a dataset property, possibly called quota-policy, that you can define as, say, strict or loose, and that way you can have if you set it to loose, ZFS would allow a user possibly to violate their quota a little bit, go, maybe a couple megabytes over what their quota is, but as a benefit to it, not have the problem of writing when your quota is almost used up being really, really slow. So they mentioned, or Chris goes on, the video for this September meeting is here and the agenda document is here. He says, this is very interesting to me because of two reasons. First, in the past, we have definitely seen significant problems with our OmniOS machines, both when the entire pool hit a quota limit or when a single file system hit its ref quota limit. It's nice to know that this wasn't just our imagination and that there is a real issue here. Even better, it might someday be improved and perhaps in a way that they could actually use at least some of the time. Second, any number of people who run very close to and sometimes at the quota limits of both file systems and pools, fundamentally because people aren't willing to buy more space. We have in the past assumed that this relatively harmless would only make people run out of space. If this is a known issue that causes serious performance degradation, well, I don't know if there's anything we can do about it, but at least we're going to have to think about it and maybe push harder at people. The first step will have to be learning the details of what's going on at the ZFS level that causes the slowdown. He said it's apparently similar to what happens when the pool is almost full, but I don't know the specifics of that either. With that said, we don't seem to have seen clear adverse effects on our Linux file servers, as they're definitely run into quota limits repeatedly. One possible reason for that is having a lot of RAM and SSDs makes the effects mostly go away. Another possible reason is that we haven't been looking closely enough to see that that we're experiencing global slowdowns that correlate to file systems hitting quota limits. We've had issues before with somewhat subtle slowdowns that we didn't understand, if I can't discount that what might have been what was happening there. So in general, the concept is, especially if you're using compression, it makes this slightly worse. You're getting close to the quota on that file system. So when you write more data, the file system, ZFS is like, well, I don't know how much your data is going to compress. So in ZFS, there are multiple transactions in flight at any one time, right? There's the open transaction group where your new writes are happening, and then there's the quiescing one where we're getting everything sorted out, and then we're actually flushing it out to disk and so on. So there are always some transactions that aren't finished ahead of you in line. And so ZFS doesn't know how much it should let you put in the currently open transaction group when you're close to the quota, because one of those preceding transaction groups might actually end up using up the last of the free space, meaning you shouldn't be allowed to write anymore. So when you get close to the quota, ZFS is like, sorry, you can't put any more in right now because what you already have in flight might fill things up. Then as that flushes and gets compressed and maybe takes up a little bit less space than it might have, we write it out and we're like, oh, okay, there's some room left. We'll let some more in. But again, we have to be slow because we have to make sure we're not going to violate that quota. Because, ZFS is like, there's a hard limit at exactly the size of that quota. We don't want to go 1 byte over.
Yeah,
but maybe in some use cases, like if you're just setting a quota of, a couple of gigs on every user's home directory, you're okay with them going 2 megabytes over their quota. So having a quota policy that says, if I'm fine with them going over the quota with what they can manage to write in 5 seconds, because you can only write so much data down in 5 seconds, right? And so rather than slowing them down constantly to make sure they don't violate that quota a little bit, we'll just we'll accept whatever you can do. And then when we actually hit the quota, we'll just say, all right, what's in flight, we'll write out, but everything after that, we'll say, sorry, full. No space. But even, this was brought up to me by actually a different FreeBSD user, Garrett Wallman, who's basically having the same problems at a different university. doing, I think it's machine learning workloads, big data sets, and so on. So I don't have a great understanding of all the intricacies of this yet. But that's why I brought it up in leadership meeting to get other people's input on it. But also, as it turns out, it helps us find other people who are having the problem, or might be, and that makes people aware of it, and also gives us a sense of how many people might be having this problem, and that might increase its priority for how we look at making the changes. So maybe this will get someone else's attention to work on this sooner than I can, because it turns out there are, a lot of big institutions using ZFS with quotas, and they would like a fix.
Yeah. Oh, yeah. But definitely good to have these discussed in the leadership meetings with a wider audience and people from different viewpoints to find the right solution, or two solutions maybe that will fit most users.
Yes, because the real problem is if you define that your quota policy is loose and they can go over, at some point you're like, how do we draw the limit of how much they can go over? And, I think my naive implementation idea would just be what's already in flight. But technically that could be up to 4 gigabytes. Now, if your quota is in terabytes, going over by 4 gigabytes is fine. But if your quota is a gigabyte and you can manage to write 4 gigabytes of data, that's probably not what you intended.
Yeah. So, that needs a bit more consideration from various angles. So these leadership meetings, again, are open to the public and also for comments, and the videos are quoted afterwards so that people can see what's going on, as Chris did apparently here. So next up, we have fixing up KA9Q-Unix, or neck deep in 30-year-old code bases, by Adrian Chad on his blog. It's called Adrian Chad's Ramblings, which I guess it is here. So Adrian writes, I'll preface this by saying, yes, I'm still neck deep in FreeBSD's Wi-Fi stack and 802.11ac support, but it turns out it's slow work to fix 15-year-old locking related issues that worked fine in 11A, B, and G cards, kind of worked okay on 11N cards, and are terrible for these 11AC cards. I'll get there. Anyhow, I've finally been mucking around with AX.25 packet radio. I've been wanting to do this since I was a teenager and found out about its existence, but back in high school and, until a few years ago, really, I didn't have my amateur radio license. But now I do, and I've done a bunch of other stuff with a bunch of other radios. The main stumbling blocks? All my devices are either Apple products or run FreeBSD, and none of them have useful AX.25 stacks. The main stacks of choice these days run on Linux, on Windows, or are full hardware TNC. So yes, I was avoiding hacking on AX25 stuff because there wasn't a BSD-compatible AX25 stack. I'm 40 now. Leave me be. But a few weeks ago, I found that someone was still running a packet BBS out of San Francisco, and amazingly, his local node ran on FreeBSD. It turns out Jeremy, his handle there is KK6JJJ, ported both an old copy of KA9Q and Norray BBS to run on FreeBSD. Cool. I grabbed my 2M radio, which is already cabled up for digital modes, compiled up his KA9Q port, figured out how to get it to speak to Direwolf, and it worked, kinda. So his config is listed there. It's a couple of lines, or just 4 of them. So after editing that, he writes, and it worked. But it wasn't fast. I mean, sure, it's 1200 bps data, but after digging around, I found a very bad stack behavior on both KA9Q and Norray. So off I went to learn about AX25. And holy hell, there are some amusing bugs. I'll still list the big showstoppers first, and then what I think needs to happen next. So he lists, let's look at the stack behavior first. So when doing LAPB over AX25, there's a bunch of frames with sequence numbers that go out, and then the receiver acts the sequence numbers 4 ways. RR, Roger, Roger, yes, I act everything up to n-1. RNR, I act everything up to n-1, but I'm full. Please stop sending until I send something back to start transmission up again. There's REJ, I received an invalid or missing sequence number. ACK everything to n-1 and retransmit the rest, please. And then there's I. This is a data frame, which includes both send and receive sequence numbers. Thus, transmitted data can implicitly ACK received data. And then he sees a couple of bursts in various configurations, and then goes into a bit more about this. It's kind of a long blog post, but it shows what kind of things you stumble into if you really get into deep into the code base and find out certain things from networking from the 80s and 90s. Oh, yeah. So I guess people should read the whole thing.
I think, a OpenBSD-based packet radio thing happening lately as well.
Oh, yeah, we mentioned something about it.
Ham BSD, we mentioned that just the other day.
Mm-hmm. Yeah, they did something there. So he closes with, if you're interested, software repositories are located below. I encourage people to contribute to the KE6JJJ work. I'm just forking off of it. GitHub username Eric Karn, and I'll be pushing improvements there. Oh, and these compile on FreeBSD. KA, 9Q, and Direwolf both compile and run on macOS 10, but Nori BBS doesn't yet do so. Yet, this does mean you can now do packet radio on FreeBSD and macOS 10. And there are the list of repositories on GitHub. Cool. So for the people who are into this kind of packet sending on this kind of AX25 stuff, definitely take a look.
So next up, we have from the Dragonfly BSD Digest, the new changes to Hammer 2 and its fsck tool are now out for review. Hammer 2 is copy on write, meaning changes are made to copies of existing data. This means operations are generally atomic and can survive a power outage, etc. And there's more links if you want to read up on that. However, there's now an fsck command, useful if you want to report data validity rather than having to do any manual repair process.
Yes.
We talked a little bit about it the other week. And so I think still, yes, the fsck utility only reports problems, it cannot fix them.
Yeah, it's not, it's just a checker, not a repair tool. But definitely good to have in case you encounter some weird file system issues on Hammer 2. You can at least run an fsck on that. Then we have the return of startx for non-root users. This is also related to an earlier BSD Now episode, but there is progress here as well to report. So over at the OpenBSD journal, they write that Mark Kettenis has recently committed changes which restore a certain amount of startx or xinit behavior or functionality for non-root users. The commit message explains it as follows. So add TTYC4 to lots of devices to change when logging in on TTYC0, and in some cases also the serial console, such that X can use it as its VT when running without root privileges. So that's the virtual terminal. And the other commit here for the Xenocara module is add a mode setting driver as a fallback when appropriate, such that we can use it when running without root privileges, which prevents us from scanning the PCI bus. This makes startx or xinit work again on modern systems with Intel DRM, Radeon DRM, and AMD GPU. In some cases, this will result in using a different driver than with XenoDM, which may expose issues, like, for example, when we prefer the Intel XORG driver, or loss of acceleration, for example, older cards supported by Radeon DRM. Okay, good to have that, so that not all X runs under root privileges or as a root user. Very nice. So, time for the Beastie Bits this week. We have an ASCII table and history, or why does Control-I insert a tab in my terminal? Over at bestascitable.com.
Yep. So to understand this, you need to understand ASCII, and to understand ASCII, you need to know a little bit about its history and the world it was developed in. So you can just read through the story, or you can just jump to the table. Teleprinters. Teleprinters evolved from the telegraph. Connect a printer and keyboard to a telegraph, and you've got a teleprinter. Early versions were called printing telegraphs. Most teleprinters communicate using the ITA2 protocol. For the most part, this would just encode the alphabet, but there were a few control codes like WRU, who are you, would cause the receiving teleprinter to send back its identification, or BEL would ring a bell, and it had a similar CR for carriage return and LF for line feed. This is all early 20th century stuff. There's no electronic computers. It's all mechanical, working with punched tape. The ITA2 and codes like it were mechanically efficient. Common letters such as E and T required only a single hole to be punched. Those 5-bit codes would only encode 32 characters, which is not even enough for just English. The solution was to add the figs and letters codes, which would switch between figures and letters mode. Figures RW would produce 42. This worked, but typoing a figures or letters or losing one in line noise would result in all kinds of gibberish. They have a great image here. A printing telegraph produced in the year 1907 is basically alphabetically sorted piano keys. Is a great example of how oftentimes what the first versions of technologies are take some existing device and modify it slightly. So in their example here, they basically put the alphabet on some piano keys and rigged it up so when you press them, it completes the circuit and makes the right noise or whatever. So letters is the very first key, and then they have A on the sharp key, and then B, and then C on a sharp, and D on the regular key, and back and forth. And they have a special command for repeat as well. And they have some, in addition to your regular numbers, they also have 1/8, 1/4, 3/8, half, 5/8, 3/4, and 7/8. A couple other common numbers you need like that. Although they seem to have 2 copies of 1/4 and 1/2 for some reason. No idea. Anyway, in the 1950s, teleprinters started to get connected to computers rather than other teleprinters. So the ITA2 protocol was designed for mechanical machines and was awkward to use. So ASCII was designed specifically for computers to use and published in 1962. Teleprinters used with computers were called terminals, as in the end of the connection, like a train terminal. Teleprinters were called TTYs, or teletypewriters. And you can still find names like DevTTY in your modern system. People really program computers using teleprinters. Here's a video of a teleprinter in action, if you want to watch it. And here's a somewhat cheesy but interesting and cute video which explains how they were used to program a PDP-11. They say terminal would connect to a computer with a serial port, RS-232, which simply transferred bytes back and forth. A terminal is more akin to a monitor with a keyboard rather than a computer in its own right. A modern monitor connected with HDMI is told, draw this pixel in this color. In 1960s, the computer merely said, here's a bunch of characters for you to print. If you're wondering what a shell is a program to interact with your computer. It provides a command line, runs programs, and displays results. The terminal just displays characters. It's like the difference between your TV and a DVD player.
Okay.
Talk more and more about that. Let's say modern systems and ASCII properties. All this matters because modern terminals operate on the same principles as those in the 1960s. If you're opening up 3 Xterms or iTerm2 windows, then you're emulating 3 terminals connected to a mainframe. If you look at the ASCII table below, then there are some interesting properties. In its first column, you can see how the left 2 bits are always set to 0, and the other 5 bits, which count up to 31, making 32 different possible combinations. The second column repeats this pattern, but with the 5th bit set to 1. Remember, read binary numbers from right to left. The interesting part here is that the letters A to Z and some punctuation map directly to the control characters in the first column. All that's needed is removing 1 bit, and it's exactly what the control key did. The control key clears the 7th bit. Lowercase and uppercase letters align in the 3rd and 4th column, and this is so that the shift key could just clear the 6th bit. So pressing Control I, lowercase, would mean sending a closing brace, which is not very useful. So some terminals interpret this as Control plus uppercase I, which sends the HT del command. Look at the table for that. Yeah, sends the HT horizontal tab. Delete is last, so all bits are set to 1. This is how you delete a character on punch tapes. Punch all the holes. So this is kind of neat and well designed, but for us, it means there's no way to see if the user pressed only Control or Shift, because from a terminal's perspective, all they do is modify a bit on the character they're actually pressing with it. So there's no way to distinguish between the Tab key and someone pressing Control plus I. It's not just the same as Tab. Control plus I is sending literally the same binary as Tab. There's no way to distinguish between Control A and Control Shift A either, because the bit that the Control clears or the Shift clears is already cleared. Sending Control with a character from the second column is useless. Control clears the 7th bit, but this is already 0, so Control and the number sign is the same as just sending the number sign. The world has not completely stood still, and there are some improvements since the 1960s, but terminals are still fundamentally ASCII-based text interfaces, and programs running inside a terminal, like a shell or Vim or whatever, still have very limited facilities for modern key events. Non-terminal programs don't have these problems as they're not restricted to this 1960s text interface.
I see. That's certainly interesting that I didn't know about.
I've never looked at an ASCII table in exactly that way before.
Yeah. Or the Control I wasn't that familiar to me that it would do a
or in
tab.
particular, that Control T is actually sending DC4, whatever that
means. Our favorite key combinations next to copy and paste.
Well, in Control R and Control S are DC2 and DC3, and I don't think we use them for anything. Should we start?
Excellent. Yeah, we will find use for that. Next up is that SourceHut makes BSD software better. Over at sourcehut.org, they write, every day SourceHut runs continuous integration for FreeBSD and OpenBSD for dozens of projects, and believe it or not, some of them don't even use SourceHut for distribution. Improving the BSD software ecosystem is important to us, and as such, our platform is designed to embrace the environment around it rather than building a new walled garden. This makes it easy for existing software projects to plug into our CI infrastructure and make BSD projects take advantage of this to improve their software. Most of the software is foundational stuff, and the improvements trickle down to the entire BSD ecosystems. So let's highlight a few of these projects that take advantage of our BSD offerings. The first thing they list is end-user software, NeoBim, and what?
The first one that's programming language.
Oh, sorry, scroll too far. Sorry. Programming language, of course. Janet, Nim, and Zig. Several programming languages use SourceHut to run BSD testing. The Janet language uses SourceHut to test both FreeBSD and OpenBSD, and fast. Each build takes only about a minute. The newest language to join us is Nim, which now uses build.sr.ht to make sure every GitHub pull request works correctly on FreeBSD and OpenBSD. The Zig project, long-lost friends of SourceHut, have also been using builds.sr.ht to test their FreeBSD support, and they host a mailing list with us too. The stability of programming languages is especially important, as bugs in a compiler or implementation will affect all software compiled with it. Thanks for using SourceHut to keep your BSD support in good shape, guys. Now comes the
this seems
software.
Like a very useful project, especially as there's more and more third-party user applications that go on ports, where it'd be really good to have their head branch constantly be built against OpenBSD and FreeBSD and so on, so that, again, as we've talked about many times, if you report the bugs as soon as they commit it, or even when they open the pull request and they haven't actually merged the change yet, when it's code they're actively working on, you're more likely to get it fixed than, 6 months later after they've done a release and we ported it, we report the problem. They're like, oh, I don't remember that code anymore. And, I'm busy working on this other stuff I've already done. I'm working on something else right now, and I won't be able to get back to that old code you're talking about for a while.
Can't be bothered, yeah. Yeah, good. So the end-user software they list is NeoVim and Mutt. End-user software gets in on the fun too, which puts more stable BSD software closer to your fingertips. The NeoVim project, a fast-moving and modern fork of the venerable Vim text editor, uses build.sr.ht for OpenBSD testing and working on using it to help fix bugs in their FreeBSD ports. They have a link there. The similarly venerable Mutt email client has also been experimenting with SourceHut recently. They're using builds.sr.ht to make sure mod compiles on FreeBSD, Alpine Linux, and Debian, and they're trying out lists.sr.ht mailing lists too. Then they have display servers, WL Roots, and Sway. One of my own projects, WL Roots, was one of the first adopters of SourceHut, to no surprise. We were also early adopters of FreeBSD support, and now we use it to test that dozens of Wayland compositors work well on the platform. Several of these tests themselves further down the stack on FreeBSD as well, such as my own Sway project and the Cage project, and more projects still are using SourceHut to test other operating systems as well. Small projects too. Lots of smaller projects have been taking advantage of SourceHut's BSD tools too to make sure they're set up right on our Berkeley friends from the start. Simon Sir's MRSH shell tests on FreeBSD, Arch Linux, and Alpine Linux. Michael Forney's Samurai project uses SourceHut builds to test 4 operating systems, including Free and OpenBSD. Hey, great. And yours, ? Want to try it yourself? Just set your own build manifest image to FreeBSD/latest or OpenBSD/latest and drop it into the submit page to give it a test drive. No need to push any half-baked test commits until it's done. Check out the compatibility page for details on builds.sr.ht support for BSDs and other operating systems, and check out our dispatch.sh.ht to add BSD-CI to your GitHub projects. Hey, are you a NetBSD expert? We need some help to finish up NetBSD support on builds.sr.ht. Get in touch. Yeah, definitely. NetBSD is missing currently on that, so that should be changed. And thanks for the SourceHut folks for that CI infrastructure. Very, very cool. Then we have in our listing of Beastie Bits, ChaosNet for Unix. So what is this? ChaosNet was an early or pre-Ethernet computer network developed at MIT. It was an early common bus packet network for all the, i.e. all the machines shared a single wire and sent packets back and forth. ChaosNet was used to connect many machines at MIT, most notably the PDP-10s running ITS and the Lisp machines. This code simulates a ChaosNet network on a single machine. There's a central server which clients connect to using Unix sockets. The server relays packets back and forth between the clients. And there's a CADR simulator, or USIM, which can be a client and uses this code to talk to the file server. File is the file serving protocol used on ChaosNet. And there's a quick start section, building instructions, and how to run it. And a bit of a ChaosNet addressing primer. Okay, interesting. From the days before there was TCP/IP networking, or when the network was just in its infancy. Next, then we have a Vim-inspired editor with a linguistic twist. This is over at cosine.blue. A Vim concerts commentary on Cocoon, the selection-oriented editor focused on interactivity and incremental results, or Maw's experiment for a better code editor. So what is Cocoon? Oh, it's called Kqn. Okay, now that they have the phonetic alphabet here. Is it Kqn? Yeah, okay. Describes itself as a code editor heavily inspired by Vim, and like the venerable VI and successor, its internal model interprets the user's keystrokes using utterances of a sort of text editing language, but with a certain linguistic twist. More on that later. Available for reasons that will later become clear, only on Unix-like systems. It was written in C++ and has a clean codebase and runs like the wind in a terminal. Maxime Costi was the author. Then they talk a bit about what the reasons are about creating that editor, and do we really need another Vim clone? And they say that it is neither a fork nor a clone. It's an effort to provide incremental results and interactivity to the selection-oriented, and code editor takes a bold step away from some of the Vim interactions familiar to many of them, or to many of us, while remaining competitive for keystroke, millisecond for precious millisecond. So the author cites the Unix philosophy as one of Kqn's virtues, and certainly it would agree that it trumps Vim in adherence there too. And that it's not easy to say it lacks enough features. And there's a twist at the end. Whereas VI's keystroke language follows verb-object order, Kqn's inverts that by following object-verb order. So in real terms, that means you make a selection object before deciding what to do, the verb, with it. The object might be a character, a word, sequence, a paragraph, parenthetical, regular expression, you name it. The verb might be delete, yank, or copy, change, indent, or even transformative operations like lint, format, and uppercase. In KQ, it is with this reverse grammar, this postfix notation, that you interactively sweep up a group of groups of characters before acting on them. That way, if your object isn't quite right, you can immediately correct it without having to undo and redo your verb. Okay, and there's more description there. It's definitely a nice way of using that, and you should check it out further if you're interested in a different language or language twist in a Vim sort of editor. Our next item is Beehive ARM64, CPU and memory virtualization on ARM v8-A. This is from papers.freebsd.org, the BSD can talk from our Romanian postdocs, I guess, Alexandru Elisei.
Yep, and it says Beehive is FreeBSD's hypervisor, and we've been working on porting it to the ARM v8 architecture. The port, which we called Beehive ARM64. We will present the current status of the project, the architecture of the hypervisor, as well as how we've used the hardware features which are designed as part of the architecture for virtualization. To provide the guests with an abstractive view of the processor, we have used a third CPU execution mode called Exception Level 2. To restrict the guest to a memory region of our choice, we have used an extra address translation step called Stage 2 Translation. This virtualization allows a host computer to run multiple virtual machines, and the ARM v8 family of processors provides various hardware features which make virtualization efficient by removing or reducing some of the overhead usually associated with running virtual machines. Beehive is FreeBSD's hypervisor and was originally created to implement these type of virtualization extensions for the x86 platform. We've been working on porting Beehive to the ARM v8 architecture. Since a hypervisor needs to have control over the memory locations that a guest virtual machine is able to access, historically this has been done by emulating the page tables in software, which can incur a significant hardware and performance penalty. To reduce this overhead, ARM has implemented a second stage of address translation called Stage 2 Translation as part of this virtualization extensions. We use this feature to isolate a region of memory which will be made available to the virtual machine, and that way the virtual machine doesn't somehow access the host memory. Next, we have a video from DEF CON 25 called Are All the BSDs Created Equally? A Survey of BSD Kernel Vulnerabilities.
Yes. Yeah, this is interesting. And now it's time for the feedback and questions section. As always, in this segment, we ask you to send us feedback and questions about the show, anything in the BSD world going on, or something that's on your mind. Send this to feedback@bsdnow.tv. So we'll have future questions in this section. Tim is the first one that we start with here about GSOC project ideas for PF rules syntax translation. Tim writes, "Hi guys, I was listening to episode 315 and Tom's question gave me an idea. I realized that porting the current version of PF to FreeBSD would be time consuming, possibly expensive, and even if successful, a moving target as the version of PF used in OpenBSD is actively developed. It occurred to me, however, that translating the PF rules from the OpenBSD syntax to the FreeBSD syntax would be a much smaller project for those features that they have in common, possibly even small enough for Google's Summer of Code. It would basically be a parsable engine with dictionaries for the operating systems. It would later be expanded to translate rule sets between different firewalls, like IPFW, for example. Another possible project would be to create docs for PF rules for various scenarios, possibly using the Book of PF scenario as a starting point. Just my 2 cents.
So, yes, changing the lexing rules in FreeBSD PF to be able to understand the newer syntax using OpenBSD's PF and basically translate it to the equivalent rule in the older syntax is probably relatively doable, although it requires understanding a lot about PF and a lot about the lexing rules. So not something I'd volunteer to do, but yes, if somebody has looked at that and thinks it's tractable, then Yeah, it'd be great to have someone do that.
Yeah. So thanks for that question. Maybe someone is picking that up. It doesn't have to be necessarily be in the Google Summer of Code. It could also be a side project outside of Google Summer of Code. But for a beginner, it's definitely a nice project to grind your tears a little bit into it, or the teeth. Brad is next with a question about Steam on FreeBSD. Brad writes, "Hi, Alan, Benedict, and JT. It was great catching up with you at VBSDCon." Ah, yes, that Brad. Okay, yeah. You were requesting questions, and I have a few, which I will try to add to the queue since you're recording double episodes for EuroBSDCon at this time where we got the message. Yep, thank you, Brad. All right. Brad writes, "I have a question, and oddly enough, it has nothing to do with ZFS." Oh, come on. That's fine. What is the current status or best practice for installing Steam on FreeBSD? It seems there are a number of threads and web posts over time. Some say it works, some say it makes a mess of FreeBSD's file system. The posts are all over the place. So he has been playing Cold Waters on FreeBSD and Wine, bought it off on Good Old Games. However, he was considering buying American Truck Simulator, Gold on Wine AppDB, but you need a Steam key to play it. Do any of you have any experience getting Wine to work on the FreeBSD?
I don't have any experience, but I know some other people have.
Yeah, it seems like it's a very selective type of applications that work, or games in particular. So I had no personal experience. Like, I would have time to play games now, but maybe some of our listeners has kind of a how-to or some more experience with those particular games or applications, if you want to call it that. Then yeah, let us know and we'll refer you, because it might be interesting to more than just Brad here. No idea. Hopefully it works better than it was before, when people were just saying it didn't work. But I have no idea or no how-to or tutorial under my belt that I can provide. But thanks for coming out to VBSDCon, Brad, and thanks for the journal article that you've written, or the little trip report for that. This is coming up in a future FreeBSD journal issue. This will come out in the next month, I'm fairly sure it will. No. Oh, yeah. No. Yeah, it does. November, December issue. So you can read what his experiences were at VBSDCon. Okay, and last in this week is Ruslan with a question about the FreeBSD quarterly status reports, the second quarter of 2019 in particular. Ruslan writes, "Hello, Alan and Benedict. Thanks for your great show." Thank you. I have a question for you. I recently read the FreeBSD quarterly status report, second quarter, and didn't understand a part of the bio_delete support for the swap pager section. The letter says that, quote, "As of this revision, in current, swap on can send bio_delete to all blocks on the specified device immediately prior to configuring it as a swap device." So, unquote. I had installed my FreeBSD 13 current AMD64 before that revision, using a snapshot, and now runs revision 351.728. When he was installing the system, I created a volume, a zvol for swap, using ZFS create, capital V, a size, -o, org.freebsd:/swap equals on, no checksumming, and the name is swap. Okay. zroot is a pool on the NVMe device that he has. Okay. Then rebooted to the just installed FreeBSD and got working. I believe swap. If you look at swapctl-l, you see this dev zvol. Jawohl, there it is. I neither changed rc.d ZFS scripts nor used swap on to enable the swapping on that zvol. And the question is, does my swap device support receive bio_delete ATA trim command? After all, I didn't issue swap on -E. I just specified the user-defined option org.freebsd:/swap for the zvol.
I don't know off the top of my head. I'm guessing you did it via fstab probably.
Yeah. So
so in general, zvols support trim, and that will cause them to free space. And then separately, ZFS knows from looking at each device and querying it whether it supports trim or not, if that makes sense.
Could be, yeah. Yeah, because typically how you add a swap zvol to your system is doing the ZFS create, and then either using swap on or listing that in your FS tab and then running that again using what's it called, mount-a if you want to run that. Yeah, but maybe that already activates the swap on -e by just listing that as the user-defined property. That needs to be looked up in the code, I guess.
So in general, what this does is trim the whole device when you first enable it for swap. Probably not something you necessarily want to do every time you boot. So it's really designed to be a one-time operation. This is more about deleting all the blocks on the swap device when you first configure it for swap. It's not something you'd want to do at every boot when you mount the swap partition. Maybe that makes more sense now.
Yeah, it must be that way. Yeah, this would make more sense. Yeah. Who wrote that code? I'm not sure. Was it a foundation project? No. That was...
Could be. I have no idea.
I need to look at the quarterly status report details. But if someone knows, then get in touch. We'll mention it in a future show. So yeah, thanks, Ruslan, for that question. And this is the end of our episode for this week. Thank you for listening, as always. And if you have anything for us, again, send this to feedback@bsdnow.tv, and we'll have future episodes to fill. Thank you, and see you next time.